Okay, this is the coastline of Namibia, and if we zoom into this sand deposit here, we will notice a large ripple formation, a kilometer in wavelength. But how can we determine if these ripples were made by wind or water? Well, there's some key features on this landscape that can help us determine that. You see this distinct edge that runs along the coastline here? This is a part of a series of accretion ridges. This is something that water forms as it's running along the edge of either a river or a coastline. So on the other side of these ripples, we find some really large accretion ridges that formed parallel with the current, just like a drumlin does. These lines show us exactly the flow of this cross-shore current. If we zoom into the edge, we find a well-pronounced accretion ridge, with a crest even taller than the surrounding ripples. And on the ocean side of this crest, you can see how more sand was washed away, just like in this stream example. And this can be found all over the Namibia coast. So now we're in the northern hemisphere on the western Sahara coast, where the paleo current now flowed to the south. We can see a large accretion ridge here, and another one over here. These are 15 kilometers apart. But the best feature is this cove. How did this cove form? Well, it formed exactly like a shallow cataract, which is a suddenly emerging channel with a U-shaped front edge. This cove is the same feature with just a less steep terrain difference. And wind is definitely not going to carve a 13-mile wide channel that happens to be at sea level. And so when we zoom out here, this huge sand pattern that was also made by an ocean current. And if you zoom into this sand pattern, the whole thing's covered in streamlined ripples.